Now today, let's look at the directing effect in arenes. Now, one thing you need to know is this. Once the moment you get a substituent in the benzene ring, this substituent will affect where the further substitutions will take place. Okay, so this guy, the first substituent in is like an usher. He will usher the next group to either the second, third, or fourth position. He will tell you, oh, okay, you can sit on the second position. So over here, okay, the second position is over here. So that is where the next electrophile will come in. If it's a 3 directing group, it will usher him to the third position over here. So that's why the electrophile will enter over here. If it's a 4 directing group, it will direct them to the fourth position here. So in your data booklet, you will see this set of data here. You do not need to memorize this. Is in your data booklet. You will then find out that certain groups are 2,4 directing, which means these groups over here will direct the substituents to the second or the fourth position. Okay, so for example, R group, okay, R group, which is any alkyl group, anything that contains carbons, they will direct further substituents to the 2 or 4 position. Okay, anything with a lone pair over here, OH, OR, and etc. All this will direct to the second and fourth position as well. Halogens are also 2,4 directing, but they are ring deactivating, meaning they make the ring less reactive. Okay, all the groups over here are ring activating, which means they make the ring more reactive. Okay, lastly, these are the 3 directing groups over here. There's a very easy way to remember them. If I just draw out NO2 and the CN. Okay, so besides NH3+, let us ignore this for now. Besides NH3+, if you look at all of this, what they have in common is that they all have at least a double bond. Okay, they have at least a double or triple bond. So the moment you see that the substituent attached to the benzene ring has a double or triple bond directly attached to the benzene ring, it is likely to be a 3 directing group. Okay, so once again, don't need to memorize, but this is just a quick way for you to very quickly determine without even looking at the data booklet. Okay, so how do we solve questions like this? So for example, if you look at this question, we need to substitute NO2 and CH3 groups in your benzene ring. Now, you can either sub the NO2 first or the CH3 first. So let's look at what happens. If I substitute the NO2 first, okay, NO2 is 3 directing. If I want to put in the CH3 later on, the CH3 must come in the position which is third position with respect to NO2. And this is not the product I want. So therefore, this tells me that this is not the correct process. So instead, what you should do is to add the CH3 first. Okay, and because CH3 is 2,4 directing, your NO2 will then enter in the second or fourth position. And this product is the same. Okay, it's just a rotation of it. Okay, so once you have identified the correct pathway, you just fill in your reagents and conditions. So this CH3Cl, anhydrous AlCl3, heat. This will be corn HNO3, corn H2SO4, 30 degrees. Okay, a lower temperature is used because CH3 is ring activating. It makes the ring more reactive. So therefore, you do not need such a high temperature to put in your NO2 group now. Okay, once again, this is 1 minute of chemistry. We'll see you the next time.